Hi everybody, this is Mrs. Ewald signing in, and today we're going to talk about the last thing for the unit, which is limiting reactants. I love limiting reactants because it is a great review of everything, and it's a good combination for you to kind of get real-life explanation for things and understand what it's all about. So, first off, you ever hear about the conspiracy theory about hot dogs and buns? Well, if you have ever looked, a typical pack of hot dogs contains about 8 hot dogs. Versus if you go to buy, then, of course, you want some hot dog buns to go along with that. And one pack of hot dog buns usually contains about 10 buns. Do you see a problem there? So, what does this mean? So, how many complete hot dogs can you make with one pack of each? Well, you can only make 8 hot dogs. Well, what does this mean? It then means that you're going to have 2 buns left over. What would that be? That would be your excess amount. And what is your limiting factor as far as how many hot dogs you can make? Well, that would be your hot dogs, the number of hot dogs that you have on hand. This, by the way, if you've ever watched Follow the Bride, there's a great scene in there where he completely flips out because he's paying all this money for his daughter's wedding, and then he's got to do all this stuff. And so he goes to buy hot dogs, and then he goes through this whole conspiracy theory. Anyway, if you've never seen Follow the Bride, you're missing out. It's a good, wholesome movie. Go check it out. Check it out. Anyway, limiting reactant. The definition is the reactant used up first in a reaction. So the limiting reactant determines the amount of product form. Please pay attention. It's a reactant. So you're only going to be looking at those things to the left of the arrow, right? So this would be your product. So you're only concerning yourselves with the reactants to figure out what is limiting the reactant, right? So don't ever put a product for the answer of a limiting reactant. And so the excess reactant, that would be like the hot dog buns we had in our example. That is when you have more of them than you need for the reaction to occur. So we're going to be able to figure out what is in excess and then also be able to calculate exactly how much is left over. So we're going to be able to do a lot, and we're first going to start off with where we've been before, and that would just be with a balanced equation. And so looking at this equation here to make salt, very simple. I'm going to keep these examples very simple so you get the overall idea of what it is about. And so if you have 2 moles of sodium reacting with 1 mole of chlorine, you can produce 2 moles of sodium chloride. Okay. Now let's say you're working in the lab and your job is to make salt. So in the lab, you have on hand 6.7 moles of sodium and 3.20 moles of chlorine. And so we want to know, what is the limiting reactant? Well, what we're going to do first is I'm going to write out my givens just as I've always done before. So 6.70 moles of sodium and 3.20 moles of chlorine. Okay, so what I'm going to do is see, theoretically, if I have that much to start of each of my reactant, how much product could I make with that? Now, when I look at my product, in this case, I only have 1 product to end with. But if you were to have multiple products here, you're going to want to focus in on just one of them and do your problem to get to the product that is the same so you can compare. So watch what I mean. I'm going to find out when I have 6.7 moles of sodium, how much sodium chloride can I make? And if I have that much mole of chlorine, how much moles of product can I make? See how I have to compare when I go towards the same product for each roadmap problem? Okay? Now you're going to use your mole ratio. This will be 2, and this will be 2. This will be moles of sodium chloride, 2, and this will be 1. And then I'm going to solve. Now, right now, this is all mole to mole, very simple. So this will be 6.70 moles of product, and this will be 6.40 moles of product. Now, looking at those two, because they're both the same, I'm looking at this product here. Remember, again, if I were to have many of them, I would only look at one, and I compare. So of those two, which is the smallest number? Well, 6.40. So this here tells me that I would only make 6.40 moles of my product when I had this much chlorine. So this tells me then that the chlorine is limiting. It is limiting the amount of product that I can make because this is the smaller number of mole than this. So my answer to letter B then, I've already done my work for. How many moles of sodium chloride are produced? Well, that would be 6.40 moles of sodium chloride. I've already done my math there to start. Beautiful, right? Last thing is to figure out my excess amount of my excess reagent. So my chlorine is limiting, so my sodium is going to be my excess. So I know that sodium is in excess. And now I'm going to calculate how much. So what I'm going to do is, now that I know that this is my limiting, I'm going to start with that again, because that is what I'm going to use, and that is what I'm limited by, is 3.20 moles of chlorine. When I have that much, how much then of my sodium is required to make this? So I'm going to go from moles of chlorine to moles of sodium. Use my molar ratio. Sodium is 2 and chlorine is 1. And solve. And I'm going to end up with 6.40 moles of sodium chloride. Oh, big mistake. That would just be sodium. Okay, so what does this mean? It means that when I have 3.20 moles of chlorine to make my salt, I only need 6.40 moles of sodium to do that because of my molar ratio. And so, how much do I actually have in the lab? Is 6.7. So, I'm going to take 6.70 minus how much I'm actually going to use, which is 6.40, and get my amount of excess, which is 0.30 moles of sodium. That would be my answer to C. Okay, let's just do one more. Again, I'm going to keep it simple, mole to mole, but in your problems that you do in class, you're going to be going from gram to gram. And so it's the same thing. You would just have to go to mole first and then get to your molar ratio and then go back to gram. Okay? All right, here's another one. Here we have a combustion. So we're starting now with 2.70 moles of C2H4 and 6.30 moles of oxygen. So looking at this balanced equation, when I have 1 mole of C2H4 reacting with 3 moles of oxygen, I will make 2 moles of CO2 and 2 moles of water. Okay, now I have 2 different products here. Remember I was mentioning that before? Well, you're only going to focus in on one of them to figure out what's limiting. How do you know which one? Well, I would probably look to see what it is we want you to answer. And so down here it says how many moles of CO2 are produced. So we're going to zone in on CO2 as our product and compare both to that. So I'm going to set this up, go from mole of C2H4 to then mole of CO2, and make this mole of O2 to mole of CO2. Use my molar ratio. Remember, you can only use molar ratio to go from one compound to another. So this will be CO2 is 2, C2H4 is 1, and then CO2 again is 2, and O2 is 3. And then solve. So this works out to be 5.4. Ooh, I should watch my sig figs on that. Make that 5.40 moles of CO2. And this would be 4.20 moles of CO2. So comparing those two, which one is smaller? This one, right? So that means when we use this much oxygen, we'll only make 4.20 moles of CO2, right? So this here means that oxygen is limiting. So I'm limited by the amount of oxygen that I have. Going through, I've already answered letter B. So how many moles of CO2? That would be this right here. So it would be 4.20 moles of CO2. And last thing is my excess. So if oxygen is my limiting, that means my C2H4 is going to be what I'm going to have in excess. And so I have to start with this value here because that is what I have. I want to theoretically find out how much C2H4 I would really need with that. So 6.30 moles of oxygen. Go from mole of oxygen and find out how much of my excess would I theoretically be able to make when I have this on hand with me in the lab. Use my molar ratio. So let's go back up here and check. And so there'll be 1 and 3. So 1 and 3. And solve, you get 2.1 moles of C2H4. So what does it mean? It means that when I have this much in my lab with me, I only need 2.1 moles of C2H4 to react with it to get my product that I want. And how much did I actually have in the lab? Up here, that's what you would look at. And so I'm going to just simply take how much I actually have on hand and minus that from 2.10 to get 0.60 moles of C2H4. Okay? And that would be how much excess. So that goes through the very, very simplistic idea of what limiting reagent is about. Remember, limiting reagent, we're looking at the reactant. We are looking to see how much product can be made, compare those two values. Look to see what is the smallest number. That will then tell us when we look over here what reactant is limiting, what are we limited by, be able to figure out how much product we're making, and then also determine our excess amount. So the only thing to do that would be a little bit more advanced would be if I were to instead give you masses here, and then you would first have to go to mole using molar ratio, and then go back to gram and compare. Okay? So this is Mrs. Ewald signing out, saying happy limiting reagent, enjoy, and peace out.